Okay, so this one looks like it's going to be pretty messy, but I think that we'll be able to do it. Okay, just follow the same method. Don't be scared away by those decimals. Okay, so a defender kicks a soccer ball away from her own goal. The path of the kicked soccer ball can be approximated by the quadratic function. Right? Oh, that's nice. Yeah. Right. It's parabolic path. By the quadratic function, the height as a function of x is equal to negative 0.06 x squared plus 3.168 x minus 35.34, where x is the horizontal distance traveled in meters from the goal line, and h is the height. Okay. You can determine the distance the soccer ball is from the goal line by solving the corresponding equation. How far is the soccer ball from the goal line when it's kicked? Okay, and how far does it travel before it hits the ground? So basically, when it's kicked, it's at a height of 0, right? And when it hits the ground, it's at a height of 0. So we are looking for our x-intercepts here, okay? Those are going to be the solutions of the corresponding quadratic equation, okay? So let's take our function. Well, let's take it as an equation. So we'll make it equal to 0 because we are looking for the x-intercepts here, okay? Okay, now I don't like that because I have a number in front of my x squared, and my last equation told me that if I don't want it to be that way, I just will divide by that coefficient of the x squared. So I'm going to do that. I'm going to divide everything by negative 0.06. Okay. All right, so when I do that, I end up with just an x squared, which makes me happy. Okay. And then I'm going to divide that coefficient by 0.06. And I'm going to get 52.8, so it's going to be negative, right? Okay, this part's going to be positive, so 35.34 divided by 0.06, 589. Okay. One thing I haven't done yet here is I haven't put my constant term over here on the right. Okay, so that's what it looks like when I get rid of that decimal, okay, which is kind of what I wanted to do. I'm going to complete the square, and I do that by taking 1/2 of 52.8. Okay, so 1/2 of 52.8 is 26.4. Okay, and then I want to square that to find out what my third term is going to be. So 26.4 squared is equal to 696.96. Okay, and so that's the thing that I'm going to add on here. Okay, of course I want to add the same thing over here just to keep my equation equal, right? 696. Getting a little squishy over here, right? So negative 589 plus 696.99. Okay. All right, so now I can complete the square. Okay, and remember I'm taking that half of that middle term, so that would be x, and I'm going to match the sign. So x minus 26.4, okay, squared equals 107.99. It's 96, right? Yeah, sorry. That's supposed to be a 6. And so is this. Okay. So that becomes 107.96. All right. Okay, so not the prettiest thing, right? But that's okay because you have a calculator, okay? You can't give an, well, no, that is an exact answer, but yeah, so you have a calculator, you can figure this out, so it really doesn't need to bother you that you have a decimal there, okay? Because it's not like you have to evaluate it in your head or anything. Okay, so we have x minus 26.4. Okay, so x equals 26 plus or minus the square root of 107.96. Okay, so let's find our two roots, okay? Hopefully we'll have two. So x equals 26 plus, do you want to figure out what that is? Let's take that in our calculator. We'll just go 107.96 and we'll take the square root of that. And it's about 10.39. Okay, so looking at our equation, we're looking at the nearest tenth of a meter. So x equals 10.4, okay, or not x equals 10.4, but our root equals 10.4, okay, or x equals 26 minus 10.4, okay? So that gives us two answers, 36.4 and 15.6, okay? Both of those are good answers. They're both positive, right? So we don't have an extraneous root here. And we'll just go back and check out that graphing calculator, see if we can get 36.4 and 15.6 as our answers. Okay. Oh, and you know I screwed up because I made this 26.4 this 26.4 into 26. So let's put that 0.4 back. It's not going to affect too much, right? So x equals 26.4 plus 10.4, that's 36.8, and 26.4 minus 10.4, which just gives us 15. Okay, so yeah, little mistake, but no big deal. Okay, that's 16, not 15. See, they just keep coming. The mistakes, you leave them alone and they reproduce. So let's go back to our graphing calculator. We've got 36.8 and 16. Okay, so I'm going to put that in, put my original equation, right, with all that ugliness that we had to get rid of. So we'll make our coefficient 0.06, or negative 0.06. Okay, that's the coefficient of the x squared term, and the middle term, 3.1. Didn't get a decimal, I don't know why. No, 3.168, and then the constant term is negative 35.34. Okay, so we're graphing that. Okay, obviously, I'm running into some trouble here because we are not showing enough. No, something's wrong. Okay, let's zoom out and see see if we can find our graph. Oh, there it is. Okay, clearly a problem. What is our problem? Oh, you know what? There we go. I made a mistake here. I can tell that I have a problem because I know that my x-intercepts are supposed to be in the positive, and that my problem there is that I made my b negative, which is not good. And that changes everything. Okay, now I'm just going to zoom in a little. Okay. I wonder if I can recenter it. I can. I can recenter it and zoom in. That's really cool because that saves some time, right? And so you can see those intercepts. One of them is at 16.01, and we're doing to the nearest tenth, so we are okay with 16, and 36.8, which is exactly what we said, right? So, so nice. Okay, so the questions ask us, how far is the soccer ball from the goal line when it's kicked? Well, if the goal is at, if x is the horizontal distance traveled from the goal line, so 0 is at the goal, okay, they must have kicked it from 16 meters away from the goal line, and then it came down at 36.8 meters from the goal line. Okay, so the soccer ball travels from 36.8 to 16.8, or to 16, or from 16 to 36.8. Okay. So our total distance traveled from when it goes up and when it comes down. Hang on, I'm just going to put this on here. Okay, so alright, so here's what we want to say here. Okay, this is where it lands. This is where it's kicked. Okay, so total distance, okay, is 36.8 minus 16, or 20.8 meters, right? Meters? Okay, yep, 20.8 meters before it hits the ground. That's B. Okay.